Hey guys, in the previous video then we were using Pascal's triangle to find the binomial expansion coefficients for 1 plus x to the power of n. Now that's all fine and dandy until your power n gets really big. Then writing out Pascal's triangle becomes a bit of a pain, and we decided it would be quite nice if there was a formula for this, and there's good news, there is a formula for this. So what we're going to do in this video, we're going to see the formula in its rough form first of all, then we're going to have a little look at factorials, then NCR notation, which we read as N choose R, and then we're going to have a look at a much neater, nicer form of the formula. So if you like, really we're going through and deriving the formula. Okay, let's get cracking then. Okay, so first up then, in its rough form, the binomial formula for the expansion of 1 plus x to the power of n is this guy. Now I'm aware you can't see it all, we're going to go through term by term. So the first term is always 1, always. So that one's nice. Our second term then is n over 1 lots of x. Now if you like, x is just x to the power of 1. So notice here we have one factor up on top and one factor on the bottom, and our power is 1. Seems to be a link there. Okay, then our next term is n times n minus 1 over 1 times 2 times x squared, or x to the power of 2. So this time we have two factors up on top. We also have two factors on the bottom. Remember, 1 times 2 is made up of two factors, 1 and 2, and up on top, n is a factor and n minus 1 is a factor. So again, a power of 2, and we have two factors on top, two factors on the bottom. Okay, then the next term, up on top, we've got n times n minus 1 times n minus 2, and on the bottom we've got 1 times 2 times 3. Now this is our x cubed term. So again, this time we got our power of 3, and we have three factors up on the top, n minus 1 and n minus 2, and on the bottom we have three factors, 1 times 2 times 3. Now there might be something else we can start to notice here. Up on top, our factors are counting down from n. So we've got n times 1 less than n times 2 less than n, and on the bottom our factors are counting up from 1. So we've got 1 times 1 more than 1 times 2 more than 1. Okay, so that's another thing that's going to come in really handy for us. Okay, then our next term, we've got n times n minus 1 times n minus 2 times n minus 3, and on the bottom we've got 1 times 2 times 3 times 4. Now this is going to give us our x to the power 4 term. So again, up on top we've now got 4 factors, on the bottom we got 4 factors on top. We're counting down from n, on the bottom we are counting up from 1. So again, this gives us our x to the power 4 term. So this pattern carries on. We carry on counting down on the top with one extra factor every successive term, and on the bottom we carry on counting up with our factors with one extra with every successive term. So this pattern carries on, so that's what the dot represents, and then our final term is always just x to the power of n. So what happens is these factors start to cancel out. But we're going to see that in a moment after we've practiced this with one expansion, learn about factorials and stuff. Okay, so here we're going to expand 1 plus x to the power of 5 using the formula. So, our first term is going to be 1. Our second term is going to be 5 over 1x. So here remember n is equal to 5. So then our third term, well, that's going to be 5 times 5 minus 1, which is 4. So 5 times 4. And then on the bottom, we're going to have 1 times 2. And that is our x squared term. And our next term is going to be, well, up on top, 5 times 4 times 3. And on the bottom, 1 times 2 times 3. And that gives us our x cubed term. And our next one, well, this is going to be 5 times 4 times 3 times 2. And on the bottom, we're going to have 1 times 2 times 3 times 4. Now that's our x to the power of 4 term. And then our final term is going to be, so I'm going to write it out in the full term and show you why we only get left with x to the power 5. So we get 5 times 4 times 3 times 2 times 1. And on the bottom, we can get 1 times 2 times 3 times 4 times 5. And that gives us our x to the power 5 term. So, let's now sharpen this up because we can quite a lot. Okay, so let's go back to the start. So, we've still got just that one term. And then we've got 5 over 1, which is just 5. So we've got 1 plus 5 x. Now this is where the fun starts. So now we've got 5 times 4, which is 20 over 1 times 2. So that's going to give us 20 divided by 2, which is 10. So we get 10x squared. Okay, now in our next term, things start to cancel out now. So notice here, up on top, we have a factor of 3, and on the bottom, we have a factor of 3. So these two cancel out. So we've actually again just got 5 times 4 over 1 times 2. So again, our coefficient is just 10. So we also get 10x cubed. Now with the x to the power 4 term, there's even more cancelling out. So up on top, we've got a factor of 3, and on the bottom, now we've also got a common factor of 4. So that also cancels out. So this time, we've also got a common factor of 2, actually. So they cancel out as well. So here we're just left with 5 over 1. So again, we've just got 5x to the power of 4. And then with our x to the power 5 term, everything up on top is common to everything on the bottom. 5 times 4 times 3 times 2 times 1 is exactly the same as 1 times 2 times 3 times 4 times 5. So these two cancel out completely and just leave us with 1x to the power of 5. So there is our expansion of 1 plus x to the power of 5 using the formula, which is exactly the same as we would get using Pascal's triangle. Now you're probably thinking, yeah, that was still quite a bit of a pain in the ass to do. The good news is we can make this even neater and quicker. So now we're going to look at factorials quickly. Okay, so factorials then. Hopefully you saw them at GCSE when you're dealing with permutations. Basically, factorials are when we write a number with an exclamation mark after it. This means 3 times 2 times 1, or 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, or something that's going to help us out a lot. Well, that's going to help us out a lot. Something else as well though. N factorial is equal to n times n minus 1 times n minus 2 times n minus 3 all the way down to, so times dot dot dot, all the way down to 1. Now we get things that look like this on top of the coefficients of the x terms in these expansions, and we also get factorials on the bottom. So we've just seen things like 1 times 2, which is 2 factorial, 1 times 2 times 3, which is 3 factorial. So we can tidy these coefficients up using factorials, which is exactly what I'm going to show you now. Okay, so let's have a look then at going back through the formula using factorials. So our first term is 1, and our next is, well, it's nx over 1 factorial. 1 factorial is 1, and our next is n times n minus 1 over, well, 1 times 2 is 2 factorial. So that's our x squared term. The next one was n lots of n minus 1 over, sorry, n minus 1 times n minus 2. Now that was over 1 times 2 times 3, which is 3 factorial, and that was our x to the power 3 term. Now I'm going to stop there. We can notice something here. If we call our power of x r, so for the x to the power r term, the denominator, so the denominator is that power factorial. So when we have x squared, the bottom of the fraction is 2 factorial. When we have the x cubed term, the bottom of the fraction is 3 factorial. So this is going to really help us. Now what would be really handy is if we could write the top in factorial form too. And the good news is we can. So here we're going to look at the x to the power 4 term in the expansion of 1 plus x to the power of 10. So, we know by the formula, the coefficient here would be, well, it's going to be 10 times 9 times 8 times 7. So it's going to be 10 times 10 minus 1 times 10 minus 2 times 10 minus 3 all over, well, it's the x to the power 4 term, so we now know the bottom is going to be 4 factorial. Now I'm not writing in my x to the power 4 because we're only interested in the coefficient. So at the moment we can't write the top in factorial form. 10 times 9 times 8 times 7 does not go all the way down to 1, so we can't write it as a factorial. But we've got a fraction, and we know that with fractions, as long as we do the same thing to the top or bottom in terms of multiplication or division, then we are absolutely golden. So to turn 10 times 9 times 8 times 7 into a factorial, we would have to multiply by 6 times 5 times 4 times 3 times 2 times 1. So if we do that to the top, then we absolutely have to do it to the bottom as well. So we're going to multiply by 6 times 5 times 4 times 3 times 2 times 1. Now we have to do that on the top and the bottom. 4 times 3 times 2 times 1. So what we're multiplying there by is 6 factorial. 6 times 5 times 4 times 3 times 2 times 1 is 6 factorial. So what that's now going to give us up on top, well, we've now got 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So what we've now got up on top is 10 factorial. Good times. And this is now over 4 factorial 6 factorial. So now our coefficient is fully in terms of factorials, so it's a lot neater than it was before. Now we can generalize this for n's and r's. So remember, n is our power, r is the power of a certain term that we are looking at the coefficient of. So let's take a look at generalizing this. Okay then, so here n was 10, that was the power of the whole expansion, and we were looking at the x to the power 4 coefficient, so that means r was 4. So let's think about what we started off with then. So we started off with n times n minus 1 over, times n minus 2 times n minus 3 over r factorial. Now what do we then multiply the top and bottom by? Well, we then multiplied by 6 factorial. Now, in terms of our n and r here, we multiplied by n minus r factorial on the top and on the bottom. So remember what we did. Up on top we had 10 times 9 times 8 times 7. To turn that into 10 factorial, we had to multiply by 6 factorial. which was 10 minus 4, all factorial. So, that then gave us our formula, or our coefficient. It gave us n factorial on top, all over r factorial times n minus r all factorial. And that right there is the formula that we use to work out any coefficient of any powered expansion of 1 plus x to the power of n. Cool. So 1 plus x to the power of n is 1, add n choose 1 x, add n choose 2 x squared, add n choose 3 x cubed, and then that continues all the way up to x to the power of n. So guys, that's it for this video. In the next, we'll have a look at doing some example questions. Good times.